Good. So just a couple of things real quick, and then we'll just work on some more examples. I just wanted to mention a conclusion here that we have from this true-false statement, and this is Fermat's theorem. And you don't want to confuse this with Fermat's last theorem. So just as a side remark, you might take a look at the history of Fermat's last theorem. It has quite a history. Fermat had been working on this problem. You can look it up, but he had this insight that he thought he could solve the problem that didn't have a solution at the time, and he wrote it in the margin that he knows the solution, but he just doesn't have the room to write it. And so, yeah, for the next 100 or so years, people tried to figure it out. And yeah, it was even featured in a Star Trek episode. I think Captain Picard was looking for a solution to Fermat's last theorem. Anyway, um, this is Fermat's theorem. By the way, I should say, I forgot to mention, the proof has been found. And it was complex enough that people don't think that Fermat actually had a theorem, had a solution. But anyway, okay, Fermat's theorem in this case just talks about if f has a local max or min at x equals a, and f is differentiable at x equals a, then what do you think we're going to conclude? F prime at a equals 0. That's our conclusion. So notice that if f prime, note, if f prime of a equals 0, that does not mean that f has a local extrema there. It only means it's a candidate for where the local max or min may occur. Okay, so you would have to go in and we would have to check further. We would have to do some further analysis. And that is in a different section. In another section, we'll be taking a look at and trying to figure out how to determine if we have a local max or a min. Good. But for right now, we just had the one method where we used, where is it? It's the closed interval method. There it is, the closed interval method for finding a global max or min. We input a continuous function in an interval, and we output the global max and min. And we do that by how? Find critical points, build a table. I guess I didn't put that in my algorithm, did I? Jeez. Okay, how about a couple of exercises just to see how we do. I'll pause and write down the problem, and then we'll take a look at it. Okay, so here's the problem. We want to sketch the graph of a function having two local maxima, one local min, and no absolute min. So I wonder how that would work. So let's go ahead and put down our two local maxima here. Maybe might do something like that. Maybe like that. One local min. Notice the local min, it would be natural to put the local min between the two maxes, right? Ooh, we got a happy face. And then, so we have a pretty easy graph so far. Now the problem is we do not want an absolute minimum. How's that going to work? Well, number one, the function cannot be continuous, because if you had a continuous function over a closed interval, right, then we would have a minimum. So how about if we do this? How about if we let our function go down? Oh, in fact, let's be How about be simple about it? How about a vertical asymptote right there? Can I still make the interval closed, maybe from A to B? How would I do that? Well, I could just put the function, or I could put the value of the function right here. Good, so there's one example. I have two maxes, one min, and no global min, no absolute min. Very good, but the function is defined everywhere on the interval, right? Excellent. So there's lots of different ways you could have done that. This is just one. Let's pause again, and let's do something that has a weird derivative. How about that? So I'll pause, and we'll take a look at this next one. Okay, so this might be a tricky one. So f of x is the square root of the absolute value of 4x minus 3 on the interval from 0 to 1. Find the absolute max and min. So in order to find critical points, I'm going to need to differentiate this expression. And how do you differentiate absolute value? You should always rewrite the function to get rid of the absolute value function, bars first. So just as a scratch work, right? We know that the absolute value of 4x minus 3 is equal to 4x minus 3 if x is bigger than or equal to 0.3, I guess, and then minus 4x minus 3 minus 4x plus 3 if x is less than 3/4, right? And so with that, then we can say that f of x is equal to, let's go ahead and just say 4x minus 3 to the 1/2 power if x is greater than or equal to 3/4, or minus 4x plus 3 plus 3 to the 1/2 if x is less than 3/4. Good. So then, can we take the derivative now? Let's see, f prime of x will be equal to either 1/2 times 4x minus 3 to the minus 1/2 times 4 if x is greater than 3/4, and then it'll be 1/2, same thing, right? Minus 4x plus 3 to the minus 1/2 times minus 4. Good. If x is less than 3/4. Now notice that the 4x minus 3 is appearing in the denominator, right? So we are going to be having a trouble at 4/3. Or sorry, 3/4. Yeah. And so it looks like then the critical point here is only going to be at x equals 3/4, right? Because otherwise the derivative will not be 0, right? Because if you have 4 over, actually the 4 and the 1/2 cancel, just gives us 2 over the square root of 4x minus 3, set that equal to 0, multiply both sides by the square root, and you just get 2 equals 0, which means no solution. Good. And so you only have x equals 3/4 then as our critical point. And so now that that's pretty much all the work, right? Because now we just have to build our table of x and y. Our interval was from 0 to 1, I believe, yes. So 0, 3/4, and 1. Plug those into your y value. F of x was equal to the square root of 4x minus 3 absolute value, right? So 0 would be the square root of 3. 3/4 would be 0. And 1 would be 1. Good. Therefore, we have our max, absolute max. Right? By the way, remember absolute max means the same thing as global max. And we have a min, absolute min. Very good. And so our absolute min occurs where the function is not differentiable. Good. And so just in terms of our vocabulary again, how would we write the solution? We would say the absolute max of f is the square root of 3, and it occurs x equals 0. Similarly, you don't have to write the whole thing out if you already have one. The absolute min of f, I'll let you abbreviate this part, is 0, and it occurs when x equals 3/4. Good, but you should make your conclusion clear, right? So you want to make a clear conclusion when you're finished. Good, that's it. I think you'll be able to make it through the rest of the homework problems. We might do a few more later, but that'll take care of today's video.